Miller here with a quick video. Sorry, I don't have the webcam working. Apologies, technical difficulties. But I saw this article and I wanted to relay it to you all. Thought you might appreciate it and find value in it, especially those of you interested in skeletal muscle hypertrophy. This was an article at the time of this recording published in April of 2023 by Ottinger. Hope I said that right. As a lead author, and Jacob Wilson as a senior author, and it's called Muscle Hypertrophy Response to Range of Motion and Strength Training, a novel approach to understanding the findings. This is a strength conditioning journal. You can go look up this article. I can't show you the actual article because it isn't a public domain one as far as I can see. But I wanted to relay to you what the authors conjectured, and I think it's a good conjecture. So this is a picture that I'm using off the internet. You can go find this, but I want to give credit where credit's due again, where this came from. So this is from a article written by these authors here, and this was a picture-associated length-tension relationship. So if you're not familiar, across the x-axis is the length of the skeletal muscle, and across the y-axis is, well, the sarcomere in particular, across the y-axis is the tension that's developed as a result. So sarcomere length, sarcomere is the contractile unit of the muscle. So these little black lines represent Z lines, and these little blue things represent actin, and these little red things with little arms hanging across here, little comb-looking things. Okay, they represent myosin. Myosin has these heads where you see the myosin and actin interact. That's where you'll see force produced. These myosin heads move. Okay, think about like a caterpillar or centipede, right? Their little legs moving. Okay, and they'll pull these Z lines together. Like when you do a biceps curl, that's what's happening when you curl the weight up, right? Is these Z lines are coming to close together. The muscle's getting shorter. Okay, this red line here is total force. Okay, and this dotted line here represents active force. So this is the active action, actin and myosin. And I'm just going to give you a quick backstory here before we get into the article, which I think is interesting. And then passive force. So passive force is other things like connective tissue, fascia, tendon, right? If you kind of put this into practical, you know, if you stretch, right, if you stand with your knees straight and you touch your toes, right, you create passive tension. Okay, it's not the skeletal muscles per se that are resisting you. It's these other connective tissue pieces. Now, we know that there's some neurological factors the muscles are probably involved with this, but just for the sake of this video, okay, just assume these passive forces are indeed passive. Okay, and these are connective tissue pieces. Active force, all right. So you notice that tension is highest right here on this curve, and then it drops off when you go either direction. Okay, this one's more of a linear decline. This one's more exponential. Okay, so when we stand in anatomical positions, you're standing up with your palms up, right? Somebody's going to be, 5, but you're standing up. Okay, palms supinated. All right, that's anatomical position. Standing straight up, palms supinated. Okay, now let's say I put a dumbbell in your hand, say curl the dumbbell. All right. And so you're going to curl the dumbbell. And so you'd be on this side of the length tension relationship. And what's happening there is that you can see that we're starting to get I don't know if that's the right word here. An optimal overlap is going away, right? It's not an optimal overlap. There we go. Okay. And so now you're getting actin that's overlapping, and now myosin can't really attach. In other words, it lost its parking spot, if you want to think of it that way. If this was a bunch of rowers on a boat, now they can't put their oars in the water to pull. Okay. And so now I'm losing tension. That's why this drops over here. It's called active insufficiency. The muscle loses its tension ability. Okay. And so if at the top of biceps curl, it doesn't feel this way, but in terms of what's happening in the muscle, you're actually weaker at the top of the biceps curl, right, than when you start. Now, there's other biomechanical factors going on that make it feel like the beginning and the middle of that is much harder than, and we're talking about internal, external torques, okay, moment arms and so forth. But in terms of the muscle itself, you're actually weaker at the top. Okay, if you try to squeeze your biceps at the top, it doesn't feel as strong as if I, halfway up, I said squeeze your biceps. You feel a lot stronger in that position. Okay, so that'd be somewhere in here. All right, at full length. Okay, in other words, when you're standing, you have optimal overlap. All right, so for the biceps curl, you go back and forth on this side of the length tension relationship. This is what the author of the article is getting at. So the authors are talking about, are partial range of motion reps effective? Okay, are they always a bad thing? You see in the research literature some conflict that seems to go on with partial reps versus full reps. I mean, you go to the Bronasium too, right? Bros like to do partial range. And when is that appropriate and when isn't it? Is it ever appropriate to do partial range? What partial range will allow for is more reps, higher metabolic fatigue, typically, and constant tension. All right, so let's think about that biceps curl for a second. If you did a partial rep, so you went halfway up and down, halfway up and down, halfway up and down, halfway up and down, instead of going all the way up, okay, you're going to live in this range here where tension remains more consistent. So the authors call this the plateau, right? So you're going to remain. So if your tension can remain higher throughout your 10 reps as opposed to a full biceps curl, okay, that means that there's potential for more damage, and aka more hypertrophy. Okay? It also means because it's a partial rep, you probably can incur more metabolic fatigue, so you can do more volume is what I'm getting at. All right? So that's one potential benefit, okay, of doing partial reps. Lateral delts would fit this. You do a lateral raise. This is lateral delt, and the same thing happens as you get up to the top. Now, if you do like a butterfly lateral, this is where things get a little more complex. So if you cross, the shoulder height, then you go all the way up with the dumbbell. Now you're using upper trap fiber. So the lateral delt may not be as effective in its pulling as it once was in abduction, but now the upper trap fibers are. So that exercise, the point would be to incorporate both lat and incorporate upper trap. So don't, it's not like, well, if I go overhead, it's a complete waste of time. Not necessarily if your target is to train upper trap fibers. So what I'm saying, though, if you do your traditional seated or standing lateral raise, whatever your favorite is, okay, this is the side of the curve you live on. Now, you could do a cable pulley and let your arm go across your body. Now you start to dip in to longer lengths of the muscle. I'm talking about the deltoid. Now you're creating tension into more closer to passive forces. And so now you're starting to see tension come back up again. So if you can imagine do a lateral raise where you can sweep the arm across your body, then do your lateral raise, now you're starting to get into science. So you're kind of seeing this, I hope, on this curve, what I'm talking about. Biceps curl, you could do an incline biceps curl. And so the dumbbell would be off to your side and straight to the ground. And so that, it's basically behind your body, like a Bayesian curl, right? Same kind of thing. And so you'd start over here and then curl it, right? You'd start over here and then curl. That creates more tension on the biceps. It can create more growth. However, it also can be an irritant to the capsule. I don't particularly like those exercises because of that. And people tend to have issues with the capsule because the long head of the biceps goes into the capsule attached to the labrum. Creates friction as it moves through that capsule. But that hypothetically would create more tension over in this side, and then you'd go past midline, and then you'd curl again, okay? Now, what does this mean? Hopefully that makes sense. Let's back up a second. So let's do an RDL. So you grab the bar, right, dumbbell, or barbell, and bend your knee slightly, and you hip hinge over the side. And so we're thinking about the hamstring muscles here. Well, as you go over the side now, this is all forces that are creating longer sarcomeres, right? So you're moving the actin and myosin further away from each other. That means the ability to generate tension is more difficult. And that's true. At the bottom, of an RDL, you're not as strong as you are at the top. Okay? So what's happening there, if we just look at the active force, which is the muscle, tension will drop. Right? So your RDL 1RM is really down here, right? I mean, because you could do more if you did a partial rep. Okay? Now, for an exercise like the RDL, generating that tension, if we add it with the passive tension now, it's just the connective tissue, you can see if we combine those two, you will see that tension arises. Let's say this is a full range of motion RDL here. Okay? So you start the movement, and now passive and active force combined, and now you're generating a higher tension by going to full range. So with the RDL, you'd want to go to full range of motion. Let's say it's below your knee. Same with the squat. If we thought about the quads, okay, you'd start here standing up, and then you'd squat down. Active tension would drop. You're weaker at the bottom, right? So your true 1RM is probably down here, okay, in terms of like the actual muscle itself. But if you combine passive force, then we get a higher tension. So you'd want to go full range of motion squat, assuming that's 90 degrees at the squat, right? Glutes may even want to go a little bit deeper in order to get this, right? So if you go partial range of motion on a squat, you may end up right here. And that wouldn't be optimal to build muscle because we're trying to develop a lot of tension, right? If we're just thinking about not tempo, but tension work, okay, this would be a partial squat. Well, that's no good. Let's go all the way to full range of motion, or at least the full range of motion we can with that mobility allows, and let's gain that tension in order to tear up the muscle and generate hypertrophy. Where like a lateral raise, we could go right here and stay at the top of the tension curve as a partial rather than go over here, right, and not be able to develop as much tension at the finish. Okay? Now, I'm not advocating for partial reps necessarily. I'm just saying this is interesting. I have worked in partial reps with clients, and I will continue to do so. Okay? I do think this also plays into understanding why going to failure for some exercises is a good idea and others it isn't. So like the RDL and the squat, going to failure is not necessarily a good idea because the high tension forces are accomplished by range of motion. You don't need to go to failure. Plus, there's such a big technical issue, right? I mean, you're talking about a compound movement with technical proficiency as opposed to a single joint exercise like a lateral raise that you don't have as high as technical proficiency or threat to your spine by performing it incorrectly. So you could go to failure with those lateral raises. You can do a lot more volume, maybe partial reps as a result, and generate more metabolic fatigue, okay, as a result of that volume, and still stay on the curve, part of the curve where the tension is still the highest. That may be a good idea to do partials with biceps curls, lateral raises, but a horrible idea for squatting and RDLs, for example. Okay, in every muscle group you can go through this, and you'll find most of them still appeal to that full range of motion. Okay, full range of motion, right? Not partial reps, but there are some of those single joint exercises in particular with low technical proficiency that would appeal to partial reps and sets to failure. Hope that makes sense. If I lost you or that was just a bunch of gibbly-goop, drop me a comment and say you're full of crap maybe. I'm fine with that too. Maybe there's a muscle group you're interested in. We can think about it too. Drop that in the comment. Hope you liked this video. If you did, like it. Subscribe to the channel if you haven't already. I always joke about hitting 1,000 subs so I can live that Lambo lifestyle. Well, obviously, that Lambo probably isn't going to happen, but it would be nice to hit 1,000 subs just as, to stroke my ego a little bit. I certainly appreciate all of you who have subscribed up to this point. And I hope to make more videos in the coming days and weeks. I should have more time to do so. Again, I hope you've enjoyed the library thus far. We'll see you in the next one.